Welcome back, guys. Today we'll be turning our little spaceman into a proper character. Is not the way to do it. So today we're going to be making two scripts, one for the body rotation and one for the head tilt. Oops. So we go ahead and open up the body rotation script. And the first thing we're going to do is, for general FPS, first person shooter games, you're going to want to lock the screen and lock the mouse to the middle of the screen. So to do this, we go cursor.lockState equals cursor.lockStateMode.locked. You can either you can go confined, which will confine it within the screen, but we want it locked within the middle of the screen. So once we did that, we can start building our screen. So first we're gonna have to get a float, and we'll say this is rotation X, and for now we'll say it is 0. So once we did that, we go down here and we say this rotation X is, we're gonna plus equals it to input dot get axes mouse X. This means we'll be using the X position of where our mouse is. So say our mouse is here in the middle of the screen and we move it up here. Wait, let me draw this. We'll make another pin. So just say our mouse is here and we move the mouse up to here. All it's checking here is whether or not we're checking the X position of this. So here is the X line, and we go down here, and this is the point where it cares. It's all it's checking is this point. It doesn't care how high it is. It's just checking the X of the mouse we're using currently. So it's getting that position, and once we did that, we go ahead and technically this is all you need for it, but generally it's not the best to use. So we want to add a sensitivity to it. So we'll just say sensitivity, and we say generally 15 I found is the better one. You can go lower or higher depending the sensitivity that you want on it, how fast you want it to react and such. And we're gonna go ahead and add that to our rotation X, and we'll say multiply it by our sensitivity. Once we did that, we can go ahead and say the rotation X equals clamp angle. We're gonna sift in 3 floats on this one. So we go down here and we want to have a float function which will return a float, and this is going to feed in float angle that we want, another float, the minimum of where it can go, and float maximum. So you most likely confused of where I'm going here, so I do have a pretty little picture for you guys. So for our body rotation, we want to clamp our mouse position to not be able to go past 0 or 360, which in this case is the full circle. So that means our body will be able to travel in a full circle because it has the full range of the circle. But for this, oh, I'll get back to the side view in a minute. But this means that this is the range of where it can go. Rotate, sorry. So we want to check whether the angle that we just put in is less than 360 F, which is float. So, and if it is, we want to go ahead and add 360. So the number is never below 360. So we go back to the picture here. So never, so because you can't have a lower number than 0, which is 360 if you take it away from 360. So it is 0, sorry. We go down here, go back to our code, and we want to check if the angle that we just put in is greater than 360. We want to minus it. So all this is just doing is making sure that we don't go over or below the number that we want. So once we did that, we can sift in to the mathsf function, which is called clamp. So before we're just here preparing the angle so it doesn't go below or higher than the number we want it to be able to rotate. So, and here we just sift in the angle, the minimum, and the maximum. Oops. So you're wondering what the minimum and maximum will be. So we go up here and say public. We'll just make this private. So private. Let's make this private float. We could use an integer, but I think it doesn't really matter in this case. So we're going to say the minimum is going to be negative 360, as you guessed, and private float the maximum x is going to be, as you would probably have guessed, 360. So once we did that, we can go down here and put in our variables. So we're going to put in the rotation x as our angle, and our minimum, and our maximum. So after we did that, we're going to have to get a quaternion.
Quaternions.
So once we did that, we're going to have to get a quaternion, and to do that, a quaternion is basically just rotation. All it does is, it's a lot more complicated than just rotations, but in most cases it's just dealing with actual rotations of objects. So we're going to say the x of it is equal to quaternion dot angle axis. What this is doing, as you can read here, is it's creating an angle degree around an axis, which I'll show you here. So, oops, it's just loading. So for our body, this is the axis that it's rotating around. The green arrow here, so it's rotating around the y-axis. If you go above it, this is the way it rotates around it. So you're right here. So just in the diagram before, it's doing it from, this is the top view, and this is the rotating. So it's like a spinning top right here. So if you look from looking at a spinning top from above, you can spin it. that's the way the rotation will be dealt with. So from above top view, that is the rotation you'll be seeing. So if you won't be seeing it from above, but if you do come from the side, you'll be able to see the actual rotation. So that's all it's doing, all it's saying there. So we're going to sift in the rotation X, and for here we're saying vector 3 up. That's the axis that we want to get it on. So just like I said, top view is the X axis. The green arrow is vector 3 up. So it's pointing up. That's the one that we want to use. So after we did that, we can go ahead and actually change the rotation of our transform. And we're going to say it is equal to, we're going to have to make a reference to the original quaternion. So we go up here and say the original, we just want to store this variable. And down here, we're going to say the original rotation is equal to the current at the start local rotation. So once you did that, we go down here and say the original rotation, the current rotation should be equal to the original rotation times what rotation we got from this. And I'm pretty sure that should work, but we should always be safe when because we're going to be adding a rigid body to this. If you're not familiar with a rigid body, it is just a physics-based body, so to speak. So we're going to want to get the rigid body. We're just going to be using it for gravity and adding forces to other objects. So we're going to make a reference to this. So we're going to say the rigid body and call it RB. And down here we'll make a reference to RB is equals get component the rigid body, because it's going to be on the same thing. We don't have to do anything else than that. And we want to say when we get it, we want to freeze the rotation of it, so it doesn't mess around with our rotation. What we want to get, we want to physically get the rotation we want from it and not use the rigid body component for that. So if we go back to here and go to the body, add the rigid body, oops, and add our body rotation script and press play, it will fall down, and you can see on the left screen it rotates when you left, right, and we just keep spinning if we do this. So once we did that, we go ahead and go to the head tilt script, and luckily for us, it's the matter of copying and changing very few things. So copy and paste, and we want to change this to Y, this to Y, 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 and we don't need to get the rigid body on this script, so we can go ahead and remove all of that. And we don't need another cursor script, as we've already told it what to do in the body rotation script. So here's just a matter of changing rotation Y, rotation Y, rotation Y, rotation Y, and minimum Y, maximum Y. And now we need to change a couple of things. This, and the sensitivity. We don't want to get the X rotation here. We want to get the Y rotation. So instead of getting this one, we want to see how high it went. So we're getting this position. This is the point we're going to be checking. So if you do it with black again, oops. So if you go straight up, it's going to be checking how high you went on this. So here, and this is just checking this right here. Doesn't care how far right you went, it's just caring how far up you went. So go back to our script and we say get the y of it, and we also want to change this from not an x, we want to get the y, and instead of x say y. And this is important as well. So as I said before, for the body we're going to be rotating around this axis, the green one. For the head we want to rotate around the red one. So if we go back to my perfect drawing, here is the side view, so it rounds this axis. Instead of the top view, it rotates around this side of it. So if we go down through the script here, so we're going to be clamping it not to 360, we want to clamp it to, for simplicity's sake, we just say 60 and take off the 3's off that. So I know it says minimum y 45 and 90 here, and in our script is 60 for both, minus 60 and 60. All it's saying is we can't go further than negative 45 or 60 in our case. Can't go more than that down from 0 because it's starting here, and we can't go more than 90 degrees. So all of this we can't access through our head because we'll be breaking our neck in that case. So all it's doing is the clamp function is just saying that we can't allow the rotation y to be more than 90 or less than negative 45. So it allows it to be lower than 90 and greater than negative 45, which I try to make a analogy here, which is the speedometer on your car. It can only go so far to the left and it can't go too much, can't go all the way, can't spin around, so it restricts it by placing these things there, and it can only go up to here, and this can only rotate to here, and it can't make a full spin because we put the restrictions on it. So once we did that, we because the angle, our angle will never go more than less than or greater than these valuables down here, so it doesn't matter, we don't need to change them here. You can if you want, but there's absolutely no need for that. So go back to, we need to change this. So before I got sidetracked, we're just rotating it around this red arrow here. So once we can go to the head and put the head tilt setting on here, and I think we're ready to test it. So I think we're going to put the main camera on the head, and we want to reset the transform. So we go to the top right here and we go ahead and reset. So it is currently sitting inside the head right now. So now if we press play, I'll zoom out here. So if we press play, drop to the ground, look left, look right, and I realized there was a mistake before I did it. We don't want to use we need to sift in the negative rotation of this. It sounds weird, but you need to, so in order for it to rotate properly, we want to go the let's go to the other picture. So this is technically down of it, or up of it, but we want to sift in this way because we are adding it here. So we're adding it, and then we want to, we want to sift in this. So once we did that, I am certain that everything should be fixed. So go ahead and press play, watch him drop again. Now look up, look down, and rotate it around. Do a little ballerina dance. Look up, move to this, we can just move around, play around with it. So that's all we need to do for prototyping our player script. So we can go ahead and move on to shooting, grappling, base building, like basic survival stuff, get a player stats on here and see where it goes from there. So thank you guys for watching. Comment, make a comment if you get any errors or I didn't explain something properly or I butchered something that I tried to explain. Thank you for watching and see you guys in the next video.